Hi everyone, in this video I'm going to talk about the properties of expected values and variances for random variables. Topics: properties of expected values and variances for random variables. Okay, so I'm going to do this case by case. Case 1. Case 1, we're looking at your random variable plus c. C means a constant, so it's a value that does not change. You will get c for sure. It's a constant value. So c is a constant. And there's no uncertainty in this. So there's no uncertainty. Okay? So you always know the value of C. Always. Okay. So what is the expected value of the random variable plus a constant? So if we look at the expected value of x plus c, we know c for sure. So there's no uncertainty in c. And the only uncertainty, the only value that you need to have expectations on is your random variable x. So this equals to expected value x plus your constant. Okay. Next, what's the variance of x plus c? Okay. Again, there's no distance between your constants, right? So the constant is just one fixed value. So there's no variance for c. So this just equals to variance of x, right? So only the random variable x has uncertainty in it, so there are distances between the possible outcomes. Okay, and the standard deviation of x plus c is just the standard deviation of x, right? It's just the square root of the variance of x. This is case 1. Next, we're going to talk about case 2. Case 2 is the case that you have a constant multiplied by your random variable x. For this case, the expected value of cx equals to, c is a constant, so you just factor it out, right? Take it out. So it's equal to c expected value of x. Okay, so it's a constant, just pull it out. Okay. And then for the variance of cx, then this we have to pay attention that if you have variance for a constant multiplied by a random variable, this when you pull out the c, you need to square it. So this equals to c squared variance of x. Okay, good. Next, we need to talk about, or before we go into the standard deviation, we need to say that if you multiply your random variable by a constant, then your variance is gonna increase by the constant square. Okay, so the increase is in square term for the variance. Next, standard deviation of cx. Okay, in this case, it's just taking the square root of c squared times variance of x. But one thing we need to pay attention to be careful is that the distance, the standard deviation is a distant concept, right? So when we talk about distant concept, it kind of cannot be negative. It has to be positive value. So we make sure that we are going to take the absolute value of c, then multiply by the standard deviation of x, right? So it's possible that c is a negative value, right? So when we calculate for the standard deviation, we need to make sure that we take the absolute value of c and then multiply by the standard deviation of x. Okay, next, case 3. case 3 is the case that you have two random variables and then you add them together. So g equals to x plus y, right? These two are both random variables, and then we're gonna try to take the expected value of g, and this equals to expected value of x plus y, right? I'm just replacing it, g with x plus y. But one thing you need to know here, expectation operations, this symbol here is linear, right? You can apply linear. So this is just equals to expected value of x plus expected value of y. Okay, and next, variance of g equals to variance of x plus y. So this variance of x plus y is a big topic that I am going to devote one video to talk about this concept here. So I would say this we're going to talk about next topic, right? Because this one is a big topic here. Okay, next we are gonna have two random variables to be multiplied to each other. Case 4. Okay, case 4. It's when you have g and that's equals to x multiplied by y, right? Two random variables, you want to multiply them together. In this case, we need to talk about two subcases in this case, right? So, first case is, now let me denote what we want to find first. Yeah, so in this case, expected value of g equals to expected value of x and y. There are two subcases we need to consider. Case 1, if x and y are independent, x and y are independent. So if x and y are independent, the way you solve this becomes a bit easier, which means that expected value of g equals to expected value of x multiplied by y. You can just separate them by expected value of x multiplied by expected value of y. Okay, this you can only do this, right? Only do this if they are independent. But if they're not independent, then this formula does not work. So if x and y are dependent, then expected value of x multiplied y does not equal to expected value of x multiplied by expected value of y, right? They're not equal if they're dependent. Cool. So if they're dependent, we'll have to calculate expected value of x multiplied by y by itself. Okay. Next, I want to show you how you would calculate this value here. Okay. So example to calculate expected value of x multiplied by y. Okay. To do this example, I want to introduce you to a box that contains a lot of information, and I'll show you each single piece of information. Let me first do the box. Okay. So y and x. Okay, so we have two random variables, x and y, and then each one is gonna take on their possible outcomes, possible value. So the possible outcomes for y are 5 and 10, right? 5 and 10. For x are -2, 0, and 2. These are possible outcomes or possible values y can take on and x can take on. And then I'm going to put 0, 1 here, 0, 1, 0.1 and 0.1, 0.3, 0.2, and 0.3 and 0. These are what we call joint probabilities, right? Let's focus on 0.1. What does 0.1 here mean? It means the probability of y equals to 5 and x equals to -2 equals to 0.1. So 10% of the probability that y equals to 5 at the same time x equals to -2. So this here and any cell, right, 0.1, 0.2, 0.3, 0.3, 0, what we call joint probability. Okay, joint probability. Okay, good. What else we can do? Okay, grab pen here. If we sum up these two joint probabilities vertically, will give us 0.2. This will give us 0.5, and this will give us 0.3. Okay, and then we're going to do it horizontally. 0.3. Okay, and this one is 0.7. Okay, what do these represent? This 0.2 here is the probability that x equals to -2. Okay, and this one is the probability that x equals to 0.3. Okay, and these are what we call marginal probabilities. So these are called marginal probability. You know, they represent what is the probability for one random variable to equal to the possible outcome. So one of the possible outcomes. And this one, 0.7 here, represents the probability that for y equals to 5. And this one is for y equals to 10. Okay, so in this table here, we get the joint values. The joint values, and their joint probabilities, and we can also calculate their marginal probabilities using the joint probabilities here. Good. Well, let's solve for the expected value of x multiplied by y using this table here. Okay, we're going to solve for the expected value of x multiplied by y. Okay, so the concept stays the same, right? So we want to get all the possible combinations of x and y, multiply them together, and then times the probability that they happen, the combination happens, and then you can add them together. Kind of take the average using the joint probabilities. So what are the possible outcomes that we get? The first case is looking at this cell here, x equals to -2, y equals to 5. So x times y can take on the value of -2 times 5 that equals to -10, and -2 times 10 equals to -20, and then 0 times 5 equals to 0, and then 0 times 10 equals to 0. Okay, 2 times 10 equals to 20, and then 2 times 5 equals to 10. Okay, so these 6 are the possible outcomes that you have x and y multiply together, right? Okay, and then the next thing we will have to do is multiply by their joint probabilities, and then you can add them up. Okay, So what's the probability that this one happens is 0.1. This one is 0.1. This one is 0.1. I mean 0.3. And this one goes 0.2. And then this one is 0, right? So the probability of it happening is 0. And then this one is 0.3. Okay? And then you're gonna multiply the outcome times the probability, the joint probability, you're gonna add them up. So if we write it in terms of formula, okay, we'll have expected value of x multiplied by y equals to -10 times 0.1 plus -20 times 0.1 plus 0 times 0.3, okay, and then 0 times 0.2 plus 10 times 0.3 plus 20 times 0, and that equals to -1 minus 2 plus 3 equals to 0. Okay, so the expected value of the random variable x times y in this case is 0. Okay, so the trick or the important point here is that you need to get all the possible outcomes of the two multiply and multiply by their joint probabilities of this combination happening. Okay, good. This video concludes the concept of probabilities. Properties of expected values and variances of random variables. Thank you for watching. I'll see you in the next video.